Hi everybody, welcome to the Neo4j Online Meetup. So this week we're going to be doing a football transfer special. So that's the European definition of the word football rather than the American one. So it's soccer if you're on the other side of the pond. And so my name's Mark. So I work in the DevRel team for Neo4j in London, and with me this week I've got my colleague Jesus, so I guess I'll let you introduce yourself.
Hi everyone, I'm Jesus, also with Neo. I'm part of the field team, and I'm also like Mark, a football expert. So we're going to be talking about
so Jesus is the expert for Spanish.
For Spanish, yeah. Mostly Spanish, yeah. Big
mostly
fan
Spanish.
Of Real Madrid.
Yeah.
Just,
so if you want to send
anyone, but it's,
any of your Barcelona jokes, send those over. Okay, so just some quick housekeeping. So if you've been to one of these before, it'll be a bit revision for you. If you have any questions, though, we've got the YouTube live chat on the right-hand side, where I see a few of you are asking questions already. So we've been asked, where's Chris Waddle playing? Where should Peter Odemwingie be driving to? So you can ask your questions on there, or you can ask them on the Neo4j Slack channel if you're watching this afterwards. One other thing, this talk is very heavy with code. So we're going to be looking at how do we query football transfers using Neo4j, and so sometimes the text might be a bit blurry if you're not in 720p. So you can go to the bottom right-hand side of the window where you're viewing this, and you can change your resolution. So I would suggest doing that if you don't have it on that resolution already. And with that, we're ready to go. So how did we get the idea of football transfers? So for people, I guess, in follow football, this you may have seen some variation of this web page. So this is the BBC UK web page from the beginning of the month when Paris Saint-Germain broke the football world transfer record and bought a player called Neymar. So you can see there it's for about £200 million. And so we thought, this is quite interesting. There must be some fun graph stuff we can do with this data. And so that's where we begin. And our data set is from a website called Transfer Marker, who keep track of all the transfers that are happening. So they have, we didn't realize when we started, they have an unbelievable number of different transfers. There's some, they track all the main leagues, they track the under 23 teams for those main leagues, they track leagues you've probably never even heard of. But this screenshot,
we probably only hear the biggest transfers, but it's amazing the amount of smaller ones that take place on a daily basis, right? So especially the two times in the year when that happens, and yeah, this transfer market webpage keeps track of all of them, and it's a very, very rich data set.
Yeah. So this page here is a screenshot of the top transfers in the world. Unfortunately, this is from 2 weeks ago, so it's now out of date because the record keeps getting broken pretty much every other day at the moment. So this one's a bit out of date, but the data set we've got loaded is going to be up till yesterday. Okay, so let's have a look. So we've got this data on here. So we're not going to look at how we got the data, but effectively we've just done some scraping and created some CSV files. If you want to see that, we can post a link to the GitHub repository where we've got it. But say we had this raw data, how would we go about making a graph out of it? So the first thing is each row represents a transfer, and if you're not familiar with football, a transfer is where one player, so typically a club, owns the contract of a player for a certain amount of time, and during that contract they might choose, or sort of have it forced by the player in this case, that they want to go to another team. And so there's typically a team where they're going from, a team they're going to, and there would usually be a transfer fee associated with the player. And then you can see on the left-hand side there's some metadata about the player. So what would that look like in a Neo4j graph? So we're going to start with a bit of modeling. So the first thing is we would make a node for the player. So in this case, we've got a node representing Neymar in there, and there's only 2 bits of data that we've got about Neymar, which pretty much stay the same, which are his name and his position. So we'll make some properties for those. So properties are sort of we're using that we can put there for sort of attributes related to the entity. So in this case, information about NIMAR. So that's the first bit. So we've got a node and we've got some properties on there. And then the player is a label representing this node. And so that's so that we could, for example, go and look up and say, find me a node which has the label player that represents NIMAR. So that's cool. So that's our first bit of the model. We might then extend it and say, okay, well, that's interesting. We've got like a whole load of players, but I can't really do much with that. So next, we might want to put in a connection from the transfer to the player. So we bring in another node on the right-hand side of this diagram, and we'll label that one transfer, and then we'll put the season that happened, and we'll put the fee. So we're pulling the fee straight out of the web page, but later on we'll do some translation to make it a bit easier to deal with, and then we'll make a relationship over to the player who the transfer is for. So, and we'll call that off player, and we'll put in the age of the player when that transfer took place. And so the idea is if player was involved in multiple transfers, then there would be a different age when those different transfers took place. Right, so now we've got two nodes, both have got a single label, and we've got one relationship. The next bit of data that we can pull in is we've got the clubs involved. So we can add the from club and the to club, in this case, Barcelona and Paris Saint-Germain. So this transfer obviously is not great for you, Giuseppe, the Barcelona fan on the chat.
Giuseppe there. Hi, Giuseppe. Yeah, another rival team in Spain. But yeah, the richest club in this season, right? With they got from so you can see these amazingly high transfer from Neymar.
All right. So right. So now we've got what have we got? 4 nodes, 3 relationships. We can then add in. What's our next bit? Oh. So I've skipped ahead there a bit. So we can then add in the nationality of the player. So Neymar plays for Brazil in that case. So we add that in. And then finally, we can bring in the countries that those clubs are part of. So Barcelona is part of Spain, Paris Saint-Germain part of France. And that's the model that we're going to try and iterate our way to. And if we, this is after adding in the second highest transfer of this transfer window. So this is a player called Ousmane, I think it's Ousmane Dembele, who went from Borussia Dortmund to Barcelona. So they used a bit of that money to go and buy another player. And then again, so some bits of this graph connect with the other ones. For example, the transfer this time is to Barcelona rather than being from Barcelona, but it brings in some extra bits of graph as well. So the from club is a new one that we haven't seen, and the country is also a new one, being Germany. Oh yeah, I've then made a mistake because we could have reused the France node on the right hand side. So we could, because Dembele plays for France and Paris Saint-Germain is in France. So we don't need those 2 France nodes there. But that's what we're trying to get to. And Jesus and I have created a guide that we can run inside the Neo4j browser. So that's where we're going to live for most of this talk. And if you want to follow along either while you're watching or afterwards, you can feel free to do so using that link. I can put it in the chat for you as well, so you don't have to remember it. But now I'm just going to go across to another window that we've got open. So we're using a tool called the Neo4j Sandbox. I don't know how many of you have used this before, but if you haven't, it's probably worth having a look, and you can see the URL in my browser. So neo4j.com. If you do neo4j.com/sandbox, this one, it will then redirect you to the -v2, and you can then spin up Neo4j instances in there, and it will give you a by default 3-day sort of Neo4j playground to go and go and mess around with, do whatever you want. And you can either use, so Jesus and I are going to be using blank sandboxes here, but you can also use, there's a bunch of ones which have inbuilt data sets. We're also making use of a neat feature here. So we've both created an empty sandbox and shared it with each other. So we've got our share feature going on here, and we've got one sandbox where we've loaded the data already, and we've got one where we're gonna use it for this session. So we've got our backup in there as well. So if you were to copy paste that guide, you'll see something like this. So this is the Neo4j browser if you haven't seen it before, and you can see there's nothing in here. So it's running Neo4j 3.2.2. In the cloud for us, and there's no nodes in there, no relationship types, no properties, and so we obviously want to try and sort that out. We've got a question actually already. So from Maurice, which is about the model. Why can't we make the plays for relationship go to a league instead of going to a country? That's actually a good question. We could do that. That would be yeah, and then we could say, well, actually no. So for the player, we were trying to pull out the fact that effectively the nationality of a player. So maybe the relationship name is a bit confusing, but we're saying like, for example, Neymar plays for Brazil. Like
yeah, one's the national team they play for, another one is the league they.
But we could have represented. We could have done that. The club is in a league, and that league is part of a country, and then you could do some more complicated things. Like you could say, well, actually, then in that league, this is the top division. We could have like a ranking of the league.
Yeah, and it's true. I mean, I'm sure there are variants to the model that we've created, and people feel free to enrich it. But yeah, that's not the only possible way of modeling things.
We've then.
The other question on the data sets. So
we've got a question. Could you upload a CSV or JSON to import all that data and try it out for ourselves? So yes, if you're able to play this guide in the Neo4j browser, you'll see that on the third page we've got a link to the data sets. And we've got all the queries on there. So you're quite welcome, and in fact encouraged if you want to try it out. Okay, so just to remind ourselves, this is the model on the screen at the moment. So we've got those two transfers that we sort of manually created, and if we go to the third page, this is where we've uploaded a CSV file onto S3, and we can just so we can click on that and run it. So hopefully that will come up below. Oh, did it? I don't know what I did. I'll try again.
How you got 2 pages ahead, or what was it?
I don't know. Hang on. Maybe it's. No, I thought it would have run. I thought I ran it. I don't know where it's gone. Hang on, let's try and refresh the page. So if you run that query, you should be able to see it running on here. Hang on a second, let's just sort it out. If not, we always have it over here.
There we go.
So we'll just go back up. So if we go there, and then let's just.
You just want to pin the guide.
So we'll pin that one at the top, and then.
There we go. And
there we go. So, sorry, that's what we were hoping for. So what we've done at the moment is we've pinned the guide to the top. So if you click on the little sort of pin-looking icon on the left-hand side, that will stick that on the top. And what we've done is we've executed a query here. If you haven't used the load CSV tool before, it does much as the name suggests. So we give it a you can either give it a HTTP like URI, or in this case HTTPS, or you can give it a file path, and it will then go and load that file and effectively iterate over it. And so if we scroll down a little bit.
So answer the question before in the data set that you have the URL with the CSV file, and that contains mark a few years, right? So it's so we've loaded 2010 to 2017. So you've got 8 years worth of transfers. 8 seasons worth of transfers. And so you can see what we've got on here. So we've got all that data that we saw on the transfer market web page. We've got the seller club. We've created a timestamp as well, so you could work out exactly what date it was on. So we pulled that in. We've got like a URI, which can act as the unique identifier for a club. We've got a player URI as well. I can maybe make this a bit bigger so it's easier for you to see. And then we've got the nationality, we've got the transfer fee. Something that you'll notice in a few slides' time is that a lot of this data is not particularly clean, and so we have to do a bit of cleaning ourselves. But that's what we've got. So at the moment, we haven't imported anything. We've just used the load CSV file to explore what have we actually got in this CSV file. If we go to the next page, something that people often notice when they first use Neo4j is that it lets you do whatever you want. So you can end up just creating sort of any type of structure. There's nothing constraining you. We could create the same player multiple times. We could create 10 Neymars, we could create 100 Ronaldos, and it won't try and stop us. In this case, the constraints on the data set are actually being controlled by where we're getting the data from. And in this case, we know that there are some values which indicate uniqueness. So we're going to create some constraints in Neo4j to ensure that. So I'm just going to run these quickly. Oh, you go back. You click here.
Oh, sorry. I click next instead of play.
Yeah,
oops.
Plays up here.
Yeah, so we want to play that one. So we'll just create these unique constraints. So on player, on club, transfer. You notice it actually highlights in green after each one that I click, and then we'll do country as well. And if we want to just check that everything worked, we can click on this DB, we can click on here, and if I scroll down, you can see these are the constraints. So this is a procedure that allows you to see which constraints you've got created. So in this case, we've got that the club ID, the property ID on the label club must be unique, equally name and country, ID and player, and ID and transfer.
So basically, it won't let us create two nodes of the same type with the same value for that property, right? It will throw an exception. It won't let.
Yes, if we try to create two NIMARs with the same ID, it's going to say, that already exists. So if we scroll back up again to our guide, and this time I'm allowed to click this button.
Yeah.
So we've got a query here and to create the players. This one takes about, I think we reckoned it was about 30 seconds. So I'm just going to run it and then I'll explain what it does. So what we're doing here, so again, we're using the CSV file, the same CSV file as before. But this time, rather than just returning some things, we're actually using a keyword called merge. Now what merge does is it will make sure that something gets created, but if it already exists, so for example, if we ran it twice, then it will just return it to us. So that's exactly what we want here. If we only ran it once, actually, we could get away with a create, but since we might make a mistake and we decide, okay, I want to run it again, we'll use the merge command. And what it does, so we're saying, I want to merge, and typically when you use the merge keyword, you want to only put one property inside the curly bracket. So you're saying, I want to merge only on this property. So I want to merge only on ID. The syntax of the language will allow you to put in the other one. So you could do, I want to merge on ID, comma name, comma position, but then you're just complicating you're increasing how much work the Cypher compiler has to do. So it's got to go and check, okay, the ID is unique. Now I need to check the name and the position for every single time that you want to, for every single row, which is it's kind of unnecessary work. So a better way to do it is to pull out, to only have the unique property inside the merge, and then do you can either do an on create set, or you could just do a set. So in this case, we're saying if I run it twice, don't set those properties the second time. We've got a question, I think Jesus has something to say, about the DB constraints. So DB constraints comes by default. So it's one of the built-in procedures with Neo4j. And you can actually see, so if you do, I think it's DB, is it db.procedures?
Yeah.
DB message.
Well, it depends on the version. If you're running it on the sandbox and you pick this 322, then you have it. But if you're on older versions, you might not have it. So
yeah.
Probably the question comes from the fact that some people may know that you can extend Neo4j by creating your own custom store procedures, or even use libraries like APOC that we've talked about in other meetups. So, but this in particular is one, as Mark says, that comes with the Neo4j from 3.1, I believe.
Yeah, I think it was something like that. So I realized maybe I misunderstood the question, and Adam actually answered it on the chat. So Adam was pointing out that you don't actually need to run that DB constraints procedure to create the constraints. The constraints get created when you run that create constraint command.
Oh, right.
It's
just for listing
that's just for listing them, yeah. So it doesn't actually create any constraints. It just tells you what.
There's another way. So you can also do schema, right?
Yeah.
Except that these, well, because we have it. Run it. So if I run schema, we get it in a different format. So it's in a lightweight format. So it shows the indexes and constraint that have been defined. Except that the DB schema one, it shows you the syntax for creating one. So that's
yeah. And then, like I just pointed out, we've got a load of APOC functions in here. So APOC is a library that is maintained by the Neo4j community, and it comes by default on the Neo4j sandbox. But if you were using your own Neo4j installation, you would need to drop that into your plugins folder manually. So in the background, while we were doing that, the players have been created. So let's have a look at what we've got. So it all looks fine. So we can either get, so by default, we'll get this graph view here. So we see we've got some players. Maybe you recognize some of them from your team. And we could have a text view of them if we wanted, and it will just give us the properties. Say here's the name, the position, the ID, or we could do a table view, and you get a slightly nicer view of that. At the moment, and we could also go to our top left and have a look on here. And at the moment, we've got. So I think it's created these labels because we did some constraints on them. But there are, if you click on it, you'll see there is not actually anything in there at the moment. So at the moment, we just got the players. And then if we go to our next page, this is a way that we could, have I gone too far? Oh yeah, sorry. Oh no, yeah, so the next page, sorry. Next page, so now we can create the player countries. So what we're doing here, so we're doing this in two parts. This is a slightly more efficient way of doing it. So on the Neo4j sandbox, it has like quite a low memory limit because there are lots of Neo4js packed on the same machine. So we've been trying to work out how we can keep the memory usage of our queries very low, much lower than what you would have on a normal Neo4j instance. But what we're doing here is just another query that goes and creates the countries first, and then after we've got the countries, we'll go and connect them to the player. So this one here is the only thing we're doing here is that some players, the website doesn't have a nationality, and so we just want to filter those out. So that's what this line is doing. And then we know that a lot of the nationalities are going to be exactly the same. There's going to be loads of players from Spain, loads of players from England, loads of players from Italy, and so we'll use a distinct on there so that there's kind of no point in calling merge country with the same country over and over again. So we don't bother doing that. So that took 8 seconds to do, and then we'll just go in now we're going to be able to use another query. So we'll look up the players that we created 2 steps ago with those countries that we just created, and then we'll connect them together. So what we're saying here is that the place for relationship here is almost saying they represent that country, so their nationality is for that country. And again, we filter out a player who doesn't play for a country, and so this is maybe one interesting thing, is that just because the player doesn't have a country, we're still going to create them for our data set. It's just that they'll be missing that relationship because they don't have it.
Yeah, I was going to mention something. You might have realized that we are using the same CSV file for all the data loads that we're running, and that might be the case sometimes. Like here, where we have a large denormalized data set where we have plenty of lines, where, as Mark was saying, we have same country, the same clubs repeated many times. So what we're doing is running multiple passes over the same file to load the data. But in some cases, you will have it broken into in a more structured way. So you have maybe a file with the teams, a file with the with the countries. So yeah.
But yeah, we've been very lazy, and we're getting Neo4j to do all the work.
It's good because I would say that most of the times that's the way you get the data, I would say.
Yeah, like
from a relational data,
denormalized dumps of the data. The next thing we want to do is import the clubs, and if you remember, you might remember from the model that we have 2 different ways that the clubs are stored. So there's some clubs that are there's on every row. There's a club that's buying the player, and then there's a club that's selling the player, which makes it a bit annoying for just writing like a simple cipher statement. And so the easy way to do it, we'll just write 2 queries, one which will go and create the selling clubs, and one which will go and create the buying clubs. But that's no fun. So Jesus and I wanted to figure out, can we do this all in one go? And so we get to introduce quite a fun query. So I'll just run it in the background, and then we'll go through how it works. So I just put it up here. I'll just put it on the full screen so it's a bit easier to read. So again, we're processing the same file. Again, we're iterating through. But this time we get to use a construct called unwind. So some of you might have come across this before. And the rough idea here is that we unwind is for taking an array or a collection of items, and it will unpack them into individual rows. So what we're using it for here is we make an array with the selling club and the buying club. And we make we're basically putting a little map structure inside it, and we're making them have identical keys. So they've got URI, they've got name, and they've got country, but we pull in different fields for each of them. And then the unwind then pulls in every selling club and every buying club as its own row.
Building the collection and then unwinding it, right?
Yeah, so we're building the collection, and immediately we unpack it, and then again we filter out the clubs because there are some entries in here where they had an unknown club, so we don't need to have it. And then again, using the same distinct trick that we did for the countries, we know that there's going to be lots of clubs there multiple times because Barcelona did multiple transfers, Real Madrid did multiple transfers, so there's again no point calling the merge lots of times. So we'll use the distinct. So this is another, if you're working with CSV files, quite a handy trick there. And then pretty much similar again down here, we're just connecting them to their country. And so if we scroll down, so that's now gone and created that bit of the graph for us while we've been explaining it. So that's the clubs. So the clubs are in. And then finally, we've got to do the transfer. So this is the big one. So we'll kick this one off in the background, and then we'll go through how it works. So I just click on it again, and I'll put it full screen so you can have a look. So again, same file. This time we've got 3 matches to start with. So we know the player's already there. We know the source club, so the seller club and the buyer club are already there. The new information is the transfer. So we know the identifier for the transfer is the ID. So they've got like a unique key for the transfer. And we're going to set the season. So the season, for example, would be 2016, 2017, or 2017, 2018, or 2010, 2011. By the only bit that's slightly different is on line 9 on here. So if you load information from a CSV file, by default, it will put it as a string. We want the timestamp to be a number because we want to do some calculations on it. And so we use a function called toInteger, which will convert it from a string to a number in this case. And then the other bits are quite similar. So we're creating a link from the transfer to the player, from the transfer to the from club, and then a transfer to the to club. And I wonder whether whether it's got through. Yeah, so we were getting this weird error before, but it seemed like
it might have with the limitations that
in the sandbox. Yeah. So when we looked at this before, when we were trying it out earlier, it seems like it actually has created all the transfers despite the error. So so what we've done now, so we've just, I wonder if I can just minimize that. Yeah. So now we've got the transfers here, and if we, for example, double click on one of them, we can get like a little view of what was happening on this transfer. So we've got in blue, we've got the transfers. So this is the one I've got. I'm selecting João Pereira was involved in a transfer from Braga to Sporting CP. There was then another transfer. That's another transfer. And if we open up that one, that was for a different player, Florent Sinama Pongol. Oh, I think I remember. I remember him from a long while ago.
But basically, as you introduced in the first slides, every transfer blue note there will have 3 legs, one pointing at the player and the 2 others pointing at the 2 clubs involved in the transfer, so the from and the to.
And this player, he's involved in a lot of free transfers from the looks of it.
Yeah, that's the brilliant thing. Once you bring all the data, you see that the notes are reused, and a player is involved in a number of transfers, and a club will have multiple transfers as well. So that's what we're going to explore.
Yeah. So if we opened up some of these club ones, if we did Atletico Madrid, we probably
it might have a limit, so it will explode. But it's
So you see, we get like loads of them because Atletico Madrid loading every single transfer. These are all the transfers that Atletico Madrid have been involved in.
It's limited to 100, so you can control that from the browser as well. But it's just
thankfully it's saved us from my insanity. So that's cool. Now you might have noticed on this diagram, actually I didn't point it out, but you'll notice like at the moment it's put in the transfer fee. You notice some of them are a bit weird, like the transfer fee on the one I've got highlighted now is a hyphen, and here is a hyphen, and then some of them say loan, and some of them say a value with a pound symbol. So in our next section, we're going to have a look at how can we clean this data so that we can actually do some queries on it. So first, let's have a look at what these transfer fees look like. So we've got all sorts of information on here. So we'll just run a query. So saying match. So go and find me all the nodes with the label transfer, and then return me the transfer fees, and count how many times each fee turns up, and then show me the most popular 100 transfer fees. So if we just run that, we can have a quick look down. So if I just do a little bit of a scroll down, you see the most popular one by far. This was very surprising for us. So we've got, I think we've got 300,000 or so transfers, and 122,000 of them are free transfers. Right. 83,000 of them are question mark. 53,000 are loan, 40,000 hyphen. And so you can see this is a very common thing that we see when you're working with data sets. Yeah, so there is, like, they don't know what is for at least the question mark and the hyphen, they just don't have any information about it.
Oh, and I see you have gratuito there, which is Spanish for free, right?
So yeah, so we've got lots of different ways of saying free. We've got some where there's empty. We've got some where there's apparently 450K is a very popular loan fee. I don't know why that would be. Yeah, 139 of those, and then I think these are the absolutely free. That must be another way of saying free transfer.
Absolutely free, right? Something like
absolutely free. But then there's another spelling here of absolutely free where they've missed a very important umlaut on the
have a data quality problem here, so So,
right, so we need to try and tidy this up a bit. So what we're going to do, we're going to use a few tactics here. So the first thing is, it looks like the question mark and the hyphen are probably like, we're going to have to rule those ones out because we can't really do any numeric calculations with those, but let's just have a look and see whether there's anything useful there. So it doesn't really look like it, to be honest, does it? We've got a triple hyphen, a question mark with a space, a hyphen in the question mark.
82,000 down there.
We've got just a question mark, we've got a hyphen, we've got a question mark with an absolute phrase with a question mark. So I think what we're going to do with these is we'll just rule them out. So what we're going to do is we'll keep the data around in case we want to go and process it afterwards. But for the sake of the queries that we're going to run, we're just going to move those ones out of the way so they don't mess up our queries. And so we're going to use this query here. And what this is doing is it's saying, find me all the transfers where the property fee contains a question mark or a hyphen. So either of those, so we'll get that set of results we've just looked at. Once you find them, get rid of the transfer label, and we'll just tag them with the transfer without fee so that we can go and look at them afterwards. So if I just run that, that will then get rid of some of the transfers for us. So we'll just wait for that to run. While we're doing it, let's see how many. We'll just do a quick query. Let's just check. So this is I'm not sure if you've seen this. This is the autocomplete functionality. I think it's been there since 3.2. I think it's 3.2. So we can just do a quick check how many transfers have we got. So we're now down to, so we've got 192,000, which at least don't have a question mark or a hyphen. And if we go to the next page of the guide, we can go and tag the loans. So these are ones where, so a loan is where a player is temporarily moved from one club to another. So I suppose the most well-known version of this is there's a player called James Rodriguez who plays for Jesus' team, Real Madrid, and he is currently on loan to Bayern Munich for two years.
Yeah, I think so.
So there's usually a fixed amount of time. It's often 1 season actually. So they normally go, okay, we'll have the player for 1 season, and usually there is no fee associated with it. So you just get the player and you normally pay their salary, which is actually obviously quite a lot of money for somebody like James Rodriguez. But in this case, they've actually got a fee associated with it as well. But we can tag that with this loan label. And this is a really good domain example of where we might want to put multiple labels on the same transfer. Because if there's just a normal transfer, we're just going to have one label.
What you're doing there is you keep the transfer tag, but you add a label, but you add another label. Right?
Yeah, so we're not removing the transfer one. Yeah, so we're considering it a transfer, but it's a specific type of transfer. So this is actually quite a nice example of where we'd have 2 labels.
Right, you want to run it?
I think, did I run it already?
No, you clicked on the right again.
Yeah, so there we go. So we've got 55,000 loan transfers. And if we go right, so now we're ready to have a look at the ones which have hopefully an actual fee. So we've still got the free transfers, we've got loans, we've got another version of free transfer, and then we've got a lot of them where there is an actual value amount. So this is what we ended up with. This was through several rounds of trial and error. So we'll just run it actually, and then we can have a look what it's doing. So this is our work. This is our cleaning up the data set. And what we want to do is we want to have a way of comparing transfers against each other. So we're creating a new property. So if you work from the end backwards and then go back up, we're creating a new property called numeric fee, which is going to use a variable called numeric fee, which is what we're calculating in this part of the query. So we're going through every transfer, and what we're doing, if you start from the middle, we'll get rid of any K. So K is 1,000 in all of these. We'll replace the M, so that's million. We'll get rid of loan fee. We'll get rid of the pound sign, which then gives us a raw numeric value. And we'll then make use of the case statement to go through all of them and do some sort of transformation of the raw value into a value in individual pounds. So what we're going to end up is so if the fee was 2.3 million, we'll end up with 230 with like 5 zeros, right, instead of the abbreviated version. So you can see what we're doing is the same. If it ends in K, that means it's 1,000. So take the raw numeric value by 1,000. We'll explain why we're using this APOC function in a second. We've then got a whole load of ways of saying free. I'm not necessarily a language expert, but I put a lot of these into Google Translate, and it claims they all mean free. So I hope that some of them don't not mean free. But what we're saying is, if the fee is any of these, set the numeric fee to 0. If we don't have a fee, we'll just assume it's 0. If it's empty, it's 0. And then finally, if it ends in an M, then we'll times it by 1,000,000. So if we go back to the guide again, and let's just check that that ran. So yeah, so it's gone and set the properties on the transfers that are left. And then I think there are just a few left which don't have a fee, so we'll just quickly exclude those as well. So it was only 12. There were 12 left with no fee, so we get rid of those. So I just want to do a quick floating point revision exercise. So you probably remember this from your days of computer science, but if we do floating point arithmetic, when we times 8.37 by 1,000,000, we end up with this beautiful answer, 836,9999.9999999, and it just keeps on adding the nines, which is quite annoying. So if you were in Java land, you'd be able to use a big decimal. In Cypher, we don't have that concept, but we do have the APOC number exact mul function, which will allow us to do this. And if we just have a quick look how that works, and if instead of doing it in Cypher, we use that, we get back the value that we'd expect to get. The only thing that's annoying is you can see by the quotes is that we've still got a string, and so that's where that last bit comes in. So we'll just convert it back to a float at the end, and then it does exactly what we want. So that's the value we want. We don't want that 836,999 value. We want the actual one we're expecting. So that's just some cleanup. But that finally, after quite a bit of data cleaning and data loading, we're now ready to do some queries. So we start with, I guess, the most fun one. What are the most expensive transfers that we've got? So here I want to start. I've got a transfer. It's off a player. The transfer has a from club and a to club, and just tell me, order them by the numeric fee. So just tell me the highest ones. And so if we do that, we end up probably nothing really surprising in here. So Neymar is sitting there at the top on his own. An interesting thing about this data set is that Transfer Market only have the initial transfer fee. So you probably, if you follow the football transfer news, Ousmane Dembele's total potential fee is higher than Pogba's, but the initial fee is the same. There's also a transfer of Mbappe, but at the moment in the data set that's only considered a loan transfer signing, because they've delayed it by a year so that they can avoid. I think that's to avoid FIFA financial fair play penalty. So that one is not in the data set either. So these are the top ones of the data that is available at the moment. So that's okay. That's not a bad query, but still. So we've got a few joins there. We can then zoom in on a team. So we can say, hey, show me all the Barcelona transfers. And obviously this one's a bit painful for Giuseppe at the top. Neymar's going out. And this shows all the players that have left Barcelona. We could then, it's quite easy to change it. So we could say, okay, well, actually, let's show the players that came to Barcelona instead. Pretty easy to do. And then this is probably a bit happier view. Although, again, Neymar's in there with a bit of baiting on line 2. But you can see, so Paulinho was one of the players.
Lists, yeah.
We've got Suarez, we've got Villa. We could have a look who have Real Madrid signed. We get Bale at the top. We've got Rodriguez. We obviously don't have Cristiano Ronaldo because he's from earlier than our data set. Okay, so this query we've got the equivalent. What have we got? We've got 3 joins. So still, it's a little bit graphy, but not incredibly. If you're from the UK, obviously your political knowledge will center around the Brexit means Brexit and how our government keeps on repeating that phrase. And so we can actually run a query that shows English players going from English teams to English teams. So this is our post-apocalypse world of football, where we're not allowed to sign any players from anywhere else in the world because the British players are the best.
Premier League's going to look like in a couple of years, right?
So Premier League 2019 season. And this is what we end up with. So we've got, these are the top transfers of British players from and to British clubs. So we've got Raheem Sterling sitting there at the top, and then John Stones. So Man City have the top 3 positions. Liverpool, fantastic signing of Andy Carroll there in 4th place. Luke Shaw, and then Adam Lallana. We could do the same thing if we wanted to. We could do the same thing in Spain. So we could say, can we find the top Spanish players moving between Spanish teams? We've got David Villa, Vitolo. Are there any Real Madrid ones on there? We've got Isco down there.
Mendy. left from.
Oh yeah,
came from Real.
Yes.
And left back to Real.
Maybe you're paying attention because how do you say it?
Iyaramendi.
Yeah, I haven't got the Spanish skills to say that. It's going to make a reappearance later on. But with this query, you could also then, if you just chop off this line here, so if we chop off line 3, then it just says, okay, find me Spanish players going anywhere. And so this now we notice that the Spanish are fleecing the English, and the English are fleecing back the Spanish. So a lot of these are
filtering on the player nationality, not necessarily from a Spanish club. So you see that.
Yeah. So these are now only Spanish players, but it gets more fun if we go back to England again, because we noticed that very rarely do English players go anywhere. Obviously, if we did Wales, we get.
Oh, good point.
We should get Gareth Bale. Hopefully, the data set calls it Wales. Yeah, so there we go. So we've got so Gareth Bale. I think still though, even if we did England and Wales, I think we still only have one player who's gone out of England. So yeah, English players and Welsh players, and maybe generally British players, seem to stay. So we've got a question here. So who's played in the most teams?
No, the previous question was about the Bacon number, kind of the distance, how many degrees of separation between players. So they're suggesting that that's one of the analyses that we could run. And yes, we could, how far. I mean, we could say what's the shortest distance between player A and club B. So that's
that's a good idea. All right, let's see. We'll call it. Oh, you want it to be the Zlatan number?
Oh yeah, well, you need a larger data set because Zlatan used to move around a lot, but it's the last few years not that much. But yeah, Zlatan
we've then got Jesus' favorite one. So this is looking at the.
Oh yeah, that's an interesting one because that's there's a few players that have moved around quite a bit for quite high fees. So in particular, we'll have obviously Neymar at the top. So twice has he been transferred, and that amounts for £279 million. Amazing. And miles behind, there's Angel Di Maria.
He's the unexpected one.
Yeah,
so he did Benfica,
Real. Well, actually, Benfica, Real, Man United,
PSG. So he's got.
Still, his miles are miles behind Neymar, right?
Yeah, and then we've got Lukaku's done. He's done. Who was he originally? Was in Belgium, and then to Chelsea, and then to Everton, and then to Man United. But apparently another two.
James as well.
We then got Hammers in there, and I don't know. Most of these others have had one massive transfer, and so that bumps them. Up. So those are the big transfer footprints. Where it gets more interesting, though, is where we go and look at the adjacent transfers. So this, I think, is where we can do really some fun stuff with Neo. So what we're doing here is we're running a Actually, I'll run it again, and then we can look at it. We're running a refactoring query, which connects adjacent transfers. So an adjacent transfer is we're grouping them by player. So what we're saying is an adjacent transfer would be, so for example, Angel Di Maria had a transfer from Benfica to Real Madrid. So that would be a transfer. The adjacent transfer, i.e. the next one, would be the one where Angel Di Maria went from Real Madrid to Manchester United. And then the next one after that would be where he went from Manchester United to PSG. And so we're going to go and create a next relationship between a player's
transfer. We're building a chain of transfers, and it will be very interesting to explore that, as we're going to see. So,
so we can just have a quick check. What does it look like? What does that chain? Does it look like? So if we just click on there. So we've got, you can see there's a lot of chains of 2. We've got one in here of 3. Don't know whether we can find who's involved in that one. That's Jonathan Biabiani has been involved in a chain of 3.
Parma, Italian.
But most of the ones that's pulled back are just 2s in there. But we can run some more. But the queries we can run against this now become much more interesting. So I'll let you go through this one.
Well, yeah, one of the things we can look at now is look at the profit made by clubs. So as players come in and out of clubs, well, the teams can make a profit if they manage to sell it more expensive than what they paid for the player, or they might be losing money. So that's what this query looks at. So we see 2 consecutive transfers of the same player. So there will be a team making a profit, and if we rank it, I mean, we can have a look at the query of the pattern. But basically, we're seeing that at the top, of course, there is Neymar, where Barcelona bought it from Santos and then sold it to Paris after we have a count of the days, but basically that's probably 2-3 seasons.
Yeah.
And they made a massive profit of 120 million.
Yeah, and when we were looking at this, we thought actually that Dembele was sold pretty quickly. We're like, oh, that's like a year and
just a season. Yeah,
it's a year and a year. Yeah, it's probably last year's transfer window.
Massive profit.
Yeah, so it's 81 million. So we worked out they made Borussia Dortmund. Yeah, so the way this structure, so the profit makers on the left, and then who do they get them from? Who do they sell them to?
Yeah.
So they're making like 200k a day.
But then, Barcelona had plenty of cash to spend after having sold Neymar. So that's, So actually, that's another interesting one that we're gonna have a look now. So how money flows actually.
Yeah, but before we get there, we found this. We wanted to go and drill into that assertion. We thought Dembele is surely going to be the most profit that you could make per day for a player, but we wrote this second query, which works out what's the profit per day that people made, and we found loads of these transfers where the player only stays at a club for 1 day. So you can see here, this one here, this was a 10 million profit in 1 day, a 9.5 million profit in 1 day, 6.3 million profit in 1 day.
So that means that the AS Roma buys the player today and sells him tomorrow
immediately. Yeah. So we were thinking, oh, we must have made a mistake somewhere. We must have messed up this data. So we pulled in. So we went and had a look at the websites. This is for Andrea. I think it's Bertolacci, hopefully. And if we go and open up the transfer market page for Bertolacci, I'll just zoom it in a bit so you can see. And if you look where I've got highlighted, it is actually what happened. So for some reason, in July 2015, Genoa sold the player for 7.65 million, and the next day was sold for 18 million. So there must have been some deal.
There might be some dodgy reason there. I mean, that's very odd.
So it's very we're not really sure what it is. So if you have any idea why that would be happening, let us know in the comments. But what we can do, if we want to really see, instead, we could do some filtering. So we could say, okay, well, actually, we want to really see players who really played at a club. So let's just filter out those ones where there was a 1 day, and we'll just get the other one then. So these are the profits that are made per day. So there's still some which are very, very short amounts of time. So there's like a 6 days in there and a 15 days, which is, I mean, that's very quick to decide. Yeah, actually, I don't really like the player. But yeah, Daniel, it looks like Daniel's pointing out there's some 3-way trades. Yeah, it looks like it must be. Yeah, so they've got something arranged in advance. But you can see eventually Dembele pops in there on a mere 192,000 profit per day, and then probably the only other real one that we can see is maybe there Marquinhos. There's a profit of 23 million in 8 or 9 months. Morata.
Yeah, Morata's not bad. I mean,
but Morata was an interesting one because there was a buyback clause from Juventus. Was it Juventus? So there was a buyback clause of 30 million. Yeah. So Real Madrid kind of knew that people want him. So they were like, okay, let's get him back and we'll make the profit. But they still took like a season to do it. And then there's a few other ones where there's obviously just not been great business done. So Chelsea didn't want Kevin De Bruyne, and so they sold him for 20 million or so, and Wolfsburg were like, sweet, let's get him, and sold him on for 50 odd. And there's some, I think Rodriguez was the other one. That was a World Cup. That was a World Cup purchase.
An impressive performance in the last World Cup. And
so that's probably a whole different thing you could look at. Yeah, like performance in the World Cup.
I'm sure there are many ways in which you can enrich that data. I mean, we were thinking about actually including the number of minutes that the player actually played, because these are the number of days that he was, in theory, under a contract.
Yeah.
But if we could enrich it with the number of minutes the player played, or the number of goals, or how his position,
like were they actually good value for that?
Cool to analyze that purchase. As well,
You'd probably say Rodriguez, although he was really good for Colombia, didn't really play so much for Real. But this then leads us to even more fun. So now we can do what we call loop transfer. So this is where a player leaves a club and then at some point in the future ends up back at the same club again. And what we're using here, we're using a variable path search on line 2. So we're saying there's a player was involved in an initial transfer. They go an unspecified number of steps to another transfer. and we're saying that the first transfer and the last transfer involved the same club. We'll filter out any loan ones because there's lots of loan signings, and we'll just say that we're not going to count those. And then we do some quite fun stuff on the 5th line here. So at the moment, we've only got the transfers, but what we really want to know is what are the clubs involved? So we want to show who are all the clubs involved in that path. So what we're doing in here is inside of pattern comprehension, we're doing a map projection. So we're going and running like a mini cipher query inside our with statement. And you could also do the same thing in a return statement. And what it's doing here is going and finding us the from club and the to club for the transfers that exist in the path that we pulled out on line 2. And then again, we're doing our calculation to see how many days were involved before they got back to their initial club. And so this is where Jesus' favorite player makes
it. Mendy again. So yeah, that's where Real made an impressive deal.
So they've sold the player. Oh no, they bought the player actually, and sold them back.
The impressive deal was by Real Sociedad, right? Real Madrid is a team who ended up spending the money. So they repurchased the player
for 15 million less
than they had sold it 2 seasons before. So that's an interesting one. And a similar thing happened with Götze from.
That was a bit longer though. Yeah, that's almost 3 years. So that was World Cup transfer? No, it's just before World Cup, wasn't
it? Probably was. Yeah. And then
Luis.
Yeah.
There's some which are very quick. This one is less than 1 season here.
Yeah, and something involves several. I mean, if you scroll up a little bit, so there's an interesting one. For example, Iago Aspas, where there's 3. I mean, there's a 3-step. So he went from Celta Vigo to Liverpool, then to Sevilla, and then from Sevilla back to Celta. This is a very graphic query. I mean, I think looking at this path that the player followed is a very interesting one.
And there are some, it actually points out some more data cleanup issues. So on this one here, it's a bit odd because we somehow got like the player going from to the same team twice. So it must have like had a mistake somewhere in the translation. But mostly, is this one another good one?
Oh yeah, there is something. Yeah, that's interesting. From Dortmund, Real, Liverpool,
and then
and back to Dortmund. Yeah, so that's, I remember him.
So that might have been maybe it was a loan in there somewhere. But it's interesting. I wasn't expecting. A lot of them are just going from the club and then immediately back. We were expecting there would be many more hops in there. So it's pointed out on the chat that we could do a query to find clubs which are selling players.
We might probably run out of time, but there's a couple of interesting ones that we might.
So we'll just quickly go through the last ones we've got. So we're running sort of out of time. Another thing we can do is we can work out the money flow between teams. So this is looking at who's injecting the money into the market. So we can run this query here. So this is grouping by season. Go in and find out which club, create a relationship of called cash flow between clubs where there was a transfer of money from between them. And we're grouping by the cash flow, number of players, and then the number of seasons, the name of the season. And if we create that, and if we then
run it.
Yeah, I've run it already down here, right? I think. Yep. We can then write a query such as who received money from Real Madrid in.
You know, the autocomplete.
Yeah, so this was on here.
So it's over, I believe.
Yeah, it's done. So by default, the Neo4j browser will fill in like all relationships of anything you put on your visualization. If you want to turn it off, there's a connect result nodes option down here.
You probably want to show instead of here, what we can do is select actually the total. So how much money flowed from Real to Manchester City. So how much, the amount of money that flowed from. So this is basically an aggregate of all the players that moved from Real Madrid on a particular season, right?
Yeah.
So it's in 2010, 2011. So 72 million or 7.2
million.
So that's an interesting aggregate looked at the club level. We can we can extend that and see.
So now we've
money flows all over.
Yeah, so we're sort of going more degrees. So like Real Madrid spent some money. Who did that team spend the money with?
At least contribute to all the other purchases.
And we could change that and go 3 levels out. Equally, we can change it and just say, actually, let's see money spent by Real Madrid and received, and we get a bit of a bigger graph. So now we've got
both directions.
Now we've got both directions. So this is money coming into Real Madrid and money going out as well. So you get a much much bigger graph.
Cool.
All right, so let's go on to our next bit. So we can then sort of have a look where is the real money being transferred between. And obviously, this is distorted by the fact that we've got Paris Saint-Germain basically distorted everything by spending that big amount of money on one player. But interesting one in position 2, which we were both surprised by, is Man City has spent 96 million with Monaco in the most recent transfer window. So we were like, oh, who did they? I didn't really remember that happening. So we were like, oh, let's have a look. And so they've got Mendy and Silva. So although individually those transfers don't rank at the top, if you add them together, that's 95 million pounds. You could then narrow in on a specific season. So we could say, okay, let's see where's the biggest transfers for last season. So the Pogba transfer, obviously, Pogba and Higuain. No, is it not? Yeah, it's Higuain. Yeah. Pogba, Higuain are in positions 1 and 2. But we've then got Barcelona, Valencia. So again, who did they? I don't remember particular transfers happening there. But you can narrow in, and then you see Andre Gomez and Paco Alcacer. We reckon neither of whom have actually played in their team. So this is where we reckon actually
the number of minutes.
Number of minutes is practically going to be 0. Yeah. And so that's where we've got up to, and so we leave you with a Spanish matador at the end sign.
Yeah, this.
So someone's pointing out that for Bertolacci, there's some co-ownership of the players. So that's interesting. So it would be interesting if we could model that maybe. But just to quickly go back here, so we're approaching the hour. So I'll just go back to the presentation. So if you want to write your own queries on this, you obviously have the data set. We've modeled all of it. The input is done. If you like the talk, we've got to do our shameless self-promotion. So don't forget to subscribe to the Neo4j channel, and you'll get a notice of when the next Neo4j meetups are. And if you like the video, if you like the talk. Going on. If you're going to be in the East Coast sort of area of the US, we have Graph Connect in October, so that's in about 6 weeks' time now. So don't forget to join us there. If you want a discount code for that, devrel@neo4j.com, and we can probably sort you out. And then before we do questions, don't forget next week we're going to be doing same time talk about efficient graph algorithms. So this is a new package of algorithms that we've recently created which run graph algorithms directly on Neo4j. So that's the end of the talk. So we're going to wait and see if you've got any other questions. So we've had some suggestions of other types of queries that we could run. So there's a suggestion, obviously, for the Zlatan number of who is connecting everybody. We've also then had a suggestion for
the three-way
triangles. Yes, it transfers in the same week. Who's buying a player and immediately selling them. And
then the one looking at the age of the players, because it's true that some tend to train young players and then sell them for massive amounts. And he mentions Ajax, which is historically one of these teams. Who, that's another interesting one. Yeah.
And then the other thing we haven't pulled in the data for is that the agents. They have agents on the transfer market website also tracks the agents for particular players, and so we thought it would be quite interesting if you could try and see where's the agent agitating for a move, and are there certain agents who you can see they're moving these players every 2 or 3 seasons, even though there doesn't seem to be any particular. They're not necessarily. I guess they're not necessarily going to a better team. They're just going to for a lot of money to another team.
Making money flow, and they get their parts. That's it.
But I see that would be another interesting one. Like, can you see where a player has gone to a team that's actually better than the team they were in before? Like, has the big money been spent on a career move upwards, or is it just
And the other one we were talking about, Mark, was the one of the managers. So how players follow the managers from the teams. So sometimes we've seen, especially in Real, when Capello came, he brought some of the players he had in Juventus before, and we see Mourinho as well.
Mourinho buys his former players, and Guardiola
is doing the same.
Guardiola is trying to get
in
Sanchez.
Munich, and now doing it in
so he did Alcantara to Bayern, and then he's got Sanchez is trying to get to City. So
I guess you have plenty of ways to enrich the data set, and publish it.
So you can just follow that guide, and then the data's on AWS. We've got a repository as well, which I'll post the link in the comments afterwards. So it doesn't look like we've got any more questions, so I guess we can wrap up there. So thanks to all of you for joining. We hope it was useful. And obviously, there's still another 6 hours of the transfer window, so
it all can change.
It all could change, yeah. So if you're following, enjoy your evening, and we will see you next week for our next installment. So bye, everyone.
Okay, bye.